today we're looking at even symmetry or even functions or even relations. Now, relations or functions are even if they are symmetrical about the y-axis. So even relations or functions have line symmetry, or I've just written the same thing again, reflection about the y-axis. Now here's the y-axis. See, this is give me an example of what this could be. Parabola, negative x squared, what do you think, plus something or minus something? All right, good. So this is a concave down parabola shifted up. Do you think if I reflect in the y-axis, which I've just drawn in red, that the left-hand side of the graph will be the same as the right? Yes. So this is an even function. It's even because it has line symmetry or about the y-axis, or it's symmetrical about the y-axis, or you can reflect it in the y-axis. For example, if this is the point 3, then this would be the point what? Okay? You know, if this is 2, 1, then that will be negative 2, 1. All right? So it's even. Algebraically, but what we're practicing today is being able to draw them and doing it algebraically. Algebraically, if a function or a relation is even, the function of x will equal the function of negative x. Now what this means is if I substitute negative x for every value of x in my function, then the function will remain unchanged. Okay? Now look, this is also an even function because if I reflect in the y-axis, look, this is negative 3 here, 3 there. This might be, I don't know, 2, 2. This might be negative 2, 2. Can we see that that is an axis of symmetry there? So, girls, a relation or a function is even if its equation remains unchanged when x is replaced by negative x. So here's our rule. You need to really, so for even functions or relations, the function of x equals the function of negative x. So if they say prove that this is an even function, you have to use that. Okay? Prove it algebraically. So, do we already have, for our example, we already know what the function of x is. So I've got that there, that the function of x is x squared minus 3. The function of negative x just means to replace an x with a negative x. So what do I write here? Negative x all squared minus 3, which is, what's that? No, it's not. Negative times negative is a positive. It's x squared minus 3. Because I'm squaring, ladies, I'm replacing, so the function of x is that. Function of negative x. Function of negative x, I have to replace the x with a negative x. Now the x is squared, so the negative x replaces the x. The whole thing is squared. So it's negative x in brackets squared. If you're ever squaring a negative, you must put brackets around it. Now, what's negative x times negative x? Positive x squared. So is the function of x and the function of negative x the same? So I can say function of x equals function of negative x. Therefore, it's an even function. Because look, that's my function of x there. My function of negative x is identical. Now we're going to do another one. All right. Do I need to write the original one out again? I don't think so. So function of x is that. Function of negative x means to replace each, wherever you see, remember when we first looked at functions, I did like function of 3, for example. Replace the x with a 3. Now we're replacing the x with a negative x. So this is to the power of 4, so it's negative x to the power of 4 minus 2. Now the x is squared, so I go negative x, replace the x with the negative x, squared plus 5. So if it's a negative to a power, you must put it in brackets. Now, negative x times negative, x times negative, x times negative x, negative, 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 it's a positive. What do I have here? X to the power of 4 minus 2. Now, what's negative x squared? Negative x, it's just x squared. So that bit stays the same, but the minus 2 stays the same too. And plus 5. So this is function of negative x. Now, so therefore, the function of x equals the function of negative x. So therefore, so we write, So some people like to write, yeah, function of negative x is that. Some people actually put on the bottom line, well, that is the function of x. That's how some people, and you can do it as well. So if I've got function of negative x is that, which is this, and now see how that equals the original, you can put equals function of x down the bottom underneath. So function of x equals function of negative x, therefore it's an even function. But you must state the rule that the function of x equals the function of negative x, therefore it's an even function. Now, so there are two types of questions you can get. Show that this is an even function by working with the algebra, showing that function of x equals function of negative x. Now you have to learn that rule. The other way is they may show you a graph and say, are these even? And you will say, yes, these are even functions because why? As they are symmetrical about the y-axis. In other words, the y-axis is a line of symmetry. Or they can give you part of a function and you have to complete the rest of the function if it is an even function. The other thing you could be asked to complete the graphs below to create an even function. If it's even, isn't it symmetrical about here? So this is like a mirror. So where do I need to put my other points? You know what, you could fold it. You know, some people might, oh no, I can't see through. Oh yeah, oh no, a bit hard. So I do a point at 1 and another one at, yeah, -1, -2. And make sure you're coming up here. All good? If it's even, it's got to be symmetrical about the y-axis. That would make that even. Are we okay with that? Can you do the others now as well? If it's even, that's got to be your axis of symmetry. Do you know what you're doing? And you just do the same. Do you get the idea, girls? I'll let you try the other one. So it's just like your graph gets folded or reflected across here. It said complete the graphs below to create an even function. That's not part of my function, the y-axis. I'm just drawing it like that. So this one would, you know, go like that. But you might have to mark in some points. So that's this would be -1, wouldn't it? And this would be the point -2. Okay, so they're even functions. Symmetrical about the y-axis. Odd functions are not symmetrical about the y-axis. They have a different type of symmetry and it's called point symmetry. And the last time you learnt about point symmetry or symmetry about the origin was in year 7 and you probably don't even remember. Anyone remember? All right, so functions are odd if they have something called point symmetry about the origin. What is point symmetry about the origin? It's when a graph is rotated 180 degrees about the origin. Now, if your graph gets rotated 180 degrees, you know 180 degrees is half a turn, it should look identical to what you start with. I'm going to turn the page over. Notice this is like a backward cubic, isn't it? Watch when I turn the page over. Do I still have the same backward cubic? All right. And this is like a, so I'm going this way, but there is another way to do it. Wait, I think it's the same. Yeah. But that's not really just the way to do it. There is another way. The way that you can, girls, this is really important. So that's important, but this is the way that you can check that your graph has point symmetry. Look, what you can do to check if a graph's got point symmetry, you can rotate a graph 180 degrees about the origin by doing 2 reflections. Reflecting in the x-axis and then the y-axis. Or you can reflect in the y-axis and then the x-axis, and you're supposed to end up with the same function. Now, here is my graph. All right, watch. I'm going to reflect it in the y-axis and the x-axis, and I should end up with exactly the same thing. That you can rotate 180 degrees is rotate in the y-axis, so wouldn't that look like that? That's rotate in the y. And now if I, reflect in the y-axis, wouldn't it look like that? And now if you reflect it in the x, do you end up with the red line? If I reflect that in x, doesn't that end up down there? And if I reflect this in x, it ends up there. I end up with the same graph. Yes, no? All right. So if I reflect in y, I get that. And if I reflect in x, then I reflect this in x, so that will go down and this will go up. I get what I started with. So I reflect in the y-axis and then I reflect in the x-axis. So if I look at just this branch, or if I look at them both, if I reflect this in y, this one goes over there, that one goes over there. And if I reflect in x, this goes up there and that goes down there. And I end up with what I started with. Okay, let's just see if this is reflecting. So this we're saying is an odd function as well. Let's have a look. Reflector in the y-axis, it would actually go this way if I reflected in y. So if I reflect in y, you're going that way and this way. And then if I reflect that graph that I just got in x, that'll go up there and this will go down there. Do you see? So reflect in y and reflect in x. Whoa. Yeah. So reflect this in y and that in y and this in x and that in x. You end up with the same graph. Can you see it or not? The other thing you can do is, you know, it's called point symmetry about the origin. I can get my ruler and I can just pick any point on the graph over here. Right, just watch what I'm doing. So I'm going to get my ruler and I'm going to say, right, I'm going to pick a point. This point up here is 2 centimeters from the origin. I should have the same point down here, 2 centimeters from the origin on the other side, if you go through the origin, because it's called point symmetry about the origin. So if I go from here to get to that's about 2 centimeters up, to get to the same point down here is 2 centimeters down. Did you sort of see? And they should be in opposite quadrants. Quadrants 2 and 4. That's in 1 and 3. All right? So that's how you can reflect. Now, you know when we were reflecting in the x-axis, do you remember what was happening with our functions? Look. Yeah, it's negative. So that's got to do with the rule. And you know when you reflect in the y-axis, wasn't that function of x equals function of negative x? So this is reflecting in the y, and putting the negative in front on this side is like we're reflecting in the x. So the odd function rule is a bit more complicated than the even rule, and you need to learn the rule. For odd functions, function of negative x, that represents the reflection in y, equals negative function of x. Whenever you do the negative of function, it gets reflected in x. So that is the rule, and you need to know this rule for odd functions. That function of negative x equals negative function of x. Now we're going to practice those. Okay? And you can draw it the same way. Reflect in y, reflect in x. So you've got to do both sides. All right. Show that this down here is an odd function. So I need to do function of negative x first. So what's that? Put the negative in where the x is. Sorry, negative x where x is. Minus 2 times negative x. Which is... what do you get? What's negative x cubed? Negative x cubed plus 2x. That's what function of negative x is. Now remember, the rule is that the function of negative x has to equal the negative function of x. Now, negative function of x. How do I write that? Isn't it just a negative in front of all of this? So it's negative bracket x cubed minus 2x, and I should expand it. See, it's the negative of whatever the function is. So I need to expand that, and I get negative x cubed plus 2x. Does that equal that? So what I've done here, I've worked out function of negative x, and I got that. I've got the negative function of x is that, so now I can say, therefore, function of negative x equals negative function of x. Therefore, it's an odd function. Do you get that? So what you need to do, you need to know the rule. Function of negative x equals negative function of x. And you can't get it mixed up with even. Okay? So you work out what the function of negative x is. You work out what the negative function of x is. You need to make sure that they're both the same. So some people now, just after here, they go, well, that equals function of negative x, and they're finished. But you need to make the statement. You need to write down what the rule is. You can't just do that without this and say, therefore, it's odd. Yeah. What function of negative x is? By substituting a negative x for the x. And then I'm working out what the negative function of x is by just putting a negative in front of the function. So I'm working out what that is, and then I'm working out what that is and seeing if they're the same. Do you get it? So girls, that's the rule, that the function of negative x has to equal the negative function of x. So you work out what the function of negative x is by substituting negative x for x. You stop. Then you have to work out what this side is. The negative function of x is just a negative in front of that. But because it's more than one term, you put brackets around it. And then I've expanded it. Expanded. Now those two are the same. So now I can say, therefore, the function of negative x equals the negative function of x. Let's do another one. I'm going to do the function of negative x first. What do you get? 5. I'm just going to go times negative x minus negative x to the power of 5. What do you get? Negative 5x minus, is this going to be a negative? So what's minus negative? Plus x to the 5. That's what function of x is. So we stop and we work out what the negative function of x is. So you stop there. You don't need to write that on the second line. So we stop there. And now we work out what the negative of your function is. So what do you do there? You put a negative in front of the function, and then you have to expand it. Was it confusing because I wrote this twice? Like maybe if I get rid of those.
No, I just didn't realize that it was,
Yeah, you're working out two separate things. In the first one, I didn't need to work out both of them because function of x was the first thing and I didn't have to do anything to it. So negative function of x is negative of that, which is negative x. What do I get now? Plus x to the 5. Are they the same? Therefore, function of negative x equals negative function of x. Therefore, it's an odd function. So I don't need the second row here. When I say function of negative x is that and I just keep the working out, I don't need to put that. Do you get it? Now, complete the graphs to create an odd function. Remember how I said the easy way? I mean, look, you can think opposite quadrants or you can reflect it and reflect it. You want to reflect and reflect? So the dotted reflect is the first one, but that's not it. And then reflect it down. So you want to do, so we're creating an odd function. Are we okay with that? So how do you do it? You reflect first, and then you reflect again. Reflect in y, reflect in x. Don't draw the one in y solid, and then rub it out later. Do you know what I mean? Now that I've done that dotted line, I have to get rid of it. And the other thing you need to do is put what these values are. And what are they? All of them. What's that? What's this? Negative 1, negative 2. That's negative 2. This is negative 1. And that's the rest of your function. So you know what you're doing? Reflecting in y and reflecting in x. Careful. They're the same ones as we did the other page. So you reflect in, so off you go. Y and then reflect in x. It should look like that. Is that what you got? As long as you've got the point 1, negative 1, it will be okay. So that's it down there. And the last one, you're reflecting, so that's the much easier way to do it, is reflecting in y. So reflect in y would be like this. I don't want to draw that one too dark. And then reflect in x, it's coming back down. Okay, so the last one should look like that. And you're reflecting the first one, you can just rub that out when you're done. Do you know what I mean? So I can sort of see my little reflecting y there, but it's not my final one. So reflecting y, if you're asked to do that, please, to get full marks, if that is the point 1, you really need to make sure you're labeling your points. That would be -1, 1, and that would be the point -2. Okay, so making sure, so that's odd. Reflecting y, reflecting x. Reflecting y, reflecting x. Okay? Now, determining if a function is odd, even, or neither. So you want to write for even, what's the rule? Function of x equals function of -x. And for odd, the rule is function of -x equals negative function of x. So basically, what you need to do, you've got function of x already. You just need to work out function of -x. Well, that's done there as well. And negative function of x. And see, so this first one's saying show that this is neither odd nor or even. It should say nor even. So we've got function of x there. I'll write it out again. So there's your function of x. Now let's do function of negative x. And what's that? Negative x cubed plus negative x plus 1, which is, what's that? Negative x cubed minus x. Now, does that equal function of x? So function of x does not equal function of negative x, therefore it's not even. Now I've already got function of negative x, why should I do it again? Don't do it again. Now which one do I just need to do? Now, I don't need to do function of negative x again, I've already just done it. So I know it's not even, so I need to write y, that the function of x does not equal the function of negative x, therefore it's not even. Now, for odd, function of negative x, we've already done. Now I need to do the negative function of x. So I put a negative in front of everything, and then I expand my bracket. And what do you get? It's looking good, but what lets it down? The 1. So now I can say that that the function of negative x does not equal negative function of x, so it's not odd. So therefore, it's neither. Neither. And you must state the rule. If you're going to say it's not even, you've got to tell me why. Because the function of x does not equal the function of negative x. If you're going to tell me it's not odd, you've got to tell me why. Because of this rule. It doesn't follow that rule. And so it's neither even nor odd. Okay? Now, function of x equals x squared minus 6x plus 5 is odd, even, or neither. Sketch its graph to support your answer. We're going to do the algebra, and we're going to sketch the graph, and you're going to see why it does not work. Okay? I'm going to sketch the graph. To help me sketch that, can I just factorize it? What do you get? Yep. I'm going to put it equal to 0. What are the x-intercepts? All right, good. What's the y-intercept? Let's do a quick sketch, concave up or down. So it's concave up, y-intercepts 5, x-intercepts are at 1 and 5. Can you see why that? Is that graph symmetrical about the y-axis? No. For a parabola to be symmetrical about the y-axis, it's got to look like that. Or upwards, like that. It's got to be an x squared type shifted up or down only. No sideways shifts for symmetrical about. Does that look like it's got point symmetry, that if I've got something shaped here, there, I should have it over here too? It's not. Can you just tell by looking at it that it doesn't look like any of these things? See, they're even. Doesn't look like that, where it's the same on the left and the right. And it doesn't look like this, where what's over here is down there and what's over there is down here. It doesn't look like those. That one's odd, because when you rotate it 180 degrees or half a circle, it ends up on itself. But to rotate 180, you reflect that way and reflect this way. Now, let's see if I do that with my function. There is, if I reflect that up there and across there, I should have a hump sitting here. I should have this something down here. That is not, doesn't look odd or even. So it's not. By graphing, you can see not, but let's do it algebraically. So what do I need to do first? I've got my function of x. Now let's do function of negative x. Make sure you put any negatives in brackets. What have I got? X squared plus 6x. So you can see that it's not even because they're different. That's a minus, that's a plus. So it's not even. And I'll just keep going. The negative function of x is a negative in front of everything. And then you can expand that out. Now I can say, well, function of x does not equal function of, negative x. That's a negative. What a mess. Function of x does not equal function of negative x. It's not even. And I know that the function of negative x does not equal the negative function of x, so it's not odd. Okay? Sorry, that's function of negative x there. Like here, the axis of symmetry here is 3. You need the axis of symmetry to be the y-axis for it to have symmetry, to have even symmetry, to be an even function. The axis of symmetry has to be there on the y-axis to be even, not on x equals 3. All right, so that's not even, and it's definitely not odd. Like if you reflect that up there and across, the graph is not sitting on itself. You're not ending up with the same graph. All right, now we've got a few harder ones. Determine whether 3 to the power of x plus 3 to the power of negative x is odd, even, or neither. It's not that bad. You just follow the rule. So there's function of x. We've got it. Function of negative x. And you don't have to draw it. You don't have to draw it. Don't you just replace an x with a negative x? Have you, so I've got, so is it the same? Because that's 3 to the negative x. You okay? Isn't that 3 to the positive x? It's the same. Therefore, function of x equals function of negative x. Therefore, it's an even function. Now let's try and see if it's odd. I don't think it can be odd and even, girls. It can't. It can't be symmetrical about the y-axis and point symmetry. That doesn't happen. But let's just try it, but you can't. It can't be both. So it's even. You would normally be finished. You don't have to go any further. So that's the end of the question. But we could check. Let's just do, I've already got function of negative x. What do I need to do now? Negative function of x. You're going to see that that's the negative of those two. So girls, if it's even, it's not going to be odd. But if it's not even, it might be odd, or it could be neither. But it cannot be even and odd. Even, you could never draw it both even and odd either. So therefore, it's not, you don't need to do this other bit, but this is not needed what I'm doing, so therefore it's not odd. But you don't need to do both. You only need to show one of them, or show they're both not true. You don't need to do this to do this bit because it is even. You don't have to show it's even and not odd. You just need to show it's even or odd, or you could show it's odd but not even, or you could show that it's neither. It's either going to be even, odd, or neither. Not both. Not two. Because it is even. Now let's do the last one. Determine whether the last one is odd, even, or neither. No, this is a tricky one. Function of x is that. Function of negative x. Be careful. 4 times negative x. Negative x squared plus 4. You tell me what you're going to get. And I'm going to do the negative function of x over here. And that's the tricky one, the negative function of x. So this is negative 4x over x squared plus 4. So is it even? No. So function of x does not equal function of negative x, so it's not even. All right, let's keep going. The negative function of x. Now, girls, be careful. That's the negative of that. I can put the negative in front, but you've got to commit the negative to the numerator or the denominator. You can't put it on both. You can't put a negative on the numerator and the denominator because a negative divided by a negative is, yeah, so I'm going to decide, I'm just going to put it right out the front and I'm going to show you something in a minute. So it's the negative of that. But now, girls, I can put the negative either on the numerator or the denominator. It's better to put it on the numerator. So I've got the negative of that. So, girls, I just want to, so that would be negative. So I'm going to say, right, the negative's either got to go on the numerator or the denominator. Put it on the numerator because there's only one number there. So it's negative 4x over x squared plus 4. Now, I'll show you why this works. Now, is that equal to function of negative x? So therefore, I can say that the function of negative x equals the negative function of x. So therefore, it's an odd. It's odd. Now, girls, that and this are the same. Function of negative x is that. It equals negative function of x. Now, I want to show you something. Watch. Negative 3 over 6. What does that equal? What does it equal? Negative a half. Now, if you put negative 3 over 6, oh, yeah, isn't that the same as, all right, actually, no, I'll go negative 1 over 2. Isn't that the same, what's it, negative 1 over 2? And what is 1 divided by negative 2? What's a positive divided by a negative? A negative. That's also negative a half. Or I can do it with whole numbers. Negative 6 over 3. What's that equal to? Negative 2. What's negative 6 divided by 3? And what's 6 divided by negative 3? One's if I put a negative and a negative, is that going to be negative? It's going to be positive. So when you see a negative in front of a fraction, either what you need to do is commit the negative to the numerator or the denominator. But do not put them in both because you'll end up with a positive. Do you get it? So where I saw here negative function of x, you put your negative either on the, so here's my negative out the front, but I've got to decide, put it on the top or the bottom. We'll put it on the numerator because that's still negative. Okay?